Welcome to Fundamental of Electrical Engineering class. Welcome to Electrical Engineering departments. My name is Muhammad Al-Athamia. I'm originally from Jordan. I came to the United States in 2018. I did my I did my master and PhD with Auburn University. I graduated in December 2022, and I started as a postdoctoral fellow at ECE department in Auburn University, the same department, the same university. I'll be your instructor in Fundamentals of Electrical Engineering. I think this is my 12th time teaching this course, so this is number 12. So I hope you will enjoy the course with me as well. And during the teaching the course, I realize the more that I'm teaching, the more that I'm learning from students. I'm learning from your questions, from your thoughts. So this course is not easy, but at the same time it's not difficult. So you need to be up to date with this course. So basically, you need to follow up with the lectures. So you need to catch up with the lectures. So most likely, after each lecture, I encourage you to study what we covered, so you will be up to date. That's why I make a weekly quizzes. So you will see every week there will be a quiz, except the first week this week. So it will be most likely the quizzes will be in Wednesdays. So this will encourage you to be up to date with this course. Okay, let me go through the course syllabus. Okay, I think let me use the PC is better. So the course syllabus you can see in Canvas. It should be available for everyone. Then here is my information, my email address. My office is in 158 Brown Hall, or I can be in the lab 152. So you can find me in either these two office or the lab. They are next to each other. My office hours between 9 to 10, Monday, Wednesday, Friday. Most likely during my office hour, I will be in my office. But outside of my office hours, I will be in the lab. So in case if these times does not work for you, please send me an email, then we can make an appointment at any time. I prefer Monday, Wednesday, Friday. And if you cannot come in person, we can make it as a Zoom. So I'm flexible on that. And the best time or the ideal time to follow me is, or if you have any short questions, just at the end of the lecture. If you if you have time, and you can follow to me after class if you have a short question. While if you need more time, if you have time, then we can go together to my office and we can discuss information. So the TA is Montasir Mahdi. So he's gonna be responsible for grading the quizzes and the exams as well. So for any inquiries regarding to the grades, or if you have any questions regarding to the grades, the quizzes grades, or the exams, please, you need to keep in mind the first person that you need to reach is the TA. While after reaching the TA, if you, for example, you review a quiz and you realize you think you deserve more points, but you are not satisfied with the grade of the TA, you go to the TA and you're still unsatisfied, then you can reach to me. So after reaching the TA, reach to me. And every time I will be with your side. So if I understand your point of view, I'm very flexible on that. The textbook. So there is a textbook here added in Canvas. So it's called Essential of Electrical and Computer Engineering. So you can press in the textbook here, so it will follow you to Vital Source. So you can have an online access to it. Then you can read it. So keep in mind, you will be charged 77.65, something like that, in the e-bill. In case if you have the textbook or if you don't need a textbook, then you can opt out. So basically, you will see on, I think, where is it here? In files, there is a folder called All Access. There's a folder, I think. It's called All Access. Yeah, e-textbook All Access. So you can follow the procedure if you need to opt out or if you don't want the textbook, so then you can follow it here. Let's go back to. So most likely during the course, I already uploaded the notes on Canvas. So But through the textbook, sometimes I will assign some recommended problems, which will be in the textbook. So these recommended problems, I will assign them as homework, but they will be ungraded. So just like self-study, this is for you, some problems that help you in the practicing for the quizzes or practicing for the exams. So it will be complementary or additional questions that you need to follow or you need to do in order to make sure that you are understanding the concepts in the right way. Okay, so the course objectives, most likely we will go through overview about the electrical engineering analysis. So, or it's called fundamental of electrical engineering. So first we will learn, or we will try to learn the ABCs of electrical engineering. Then, after learning the alphabets, then we can start creating some words, then making some useful sentences. So basically, at the beginning of this course, we will start discussing the electrical circuits analysis, most likely based on the circuit elements like voltage source, current source. Some of them you are familiar with this from physics, but we will discuss this in another way. And resistor, inductor, capacitor, something like that. Then we will start, how about if we make a combination of resistors, something like series, parallel, then how about if we make some small circuit analysis in DC circuit analysis. Then we can expand things. So first, like the first month, we will talk about DC circuit analysis, introduction and DC circuit analysis. The second month, we will be about AC circuit analysis. So why we are using AC, then we will discuss about something called three-phase circuit analysis. After that, we are ready to go to the applications. So the applications like the power transformer, the motors, induction motors, synchronous motor, some operational amplifiers, some applications like how is the electrical system connection for residential, how is the power system overview, how the electricity will be generated until be transmitted, distribution. So we will discuss this in different points. So the overall in this course, we will discuss only the basics or the foundations or the idea. We will not go in deep details, because in deep details this will be electrical engineering major. But here we will just discuss some overview, some important things that will be so you can know the fundamental or the concept behind this. Okay, then the grading policies. So there will be weekly quizzes, 16%, 3 midterm exams, 18% each, then final exam 30%. Keep in mind the final exam is cumulative, so it's everything included from lecture number 1 until the end of this course will be included in the final exam. Okay, so the grades are assigned in percentage as A, B, C, D, and F as follows. So the exam dates has already been assigned. Then the first exam will be on Friday, February 9th. Second exam, Wednesday, March 13th. Third exam, Wednesday, April 10. Final exam, Tuesday, April 30. So keep in mind, you need to save these dates and put them in your calendar. Keep in mind, all of these dates has been assigned now. So it can avoid any future plan for you, like travel plan or some other projects, some other courses to do. So keep in mind now you already have the exam dates, so you can keep this as a reference. So then you can program that. Do the other thing that in your life based on what we have in the exams. The quizzes most likely will be weekly quizzes. So I think it will be around 10 quizzes, which will be in Wednesdays. So the first lecture, of course, no quiz. We still didn't discuss anything yet. Then the quizzes will start from the following week, next week. It's January 17th, quiz number 1, and so on, quiz 2, 3. While in the week of February, Wednesday, February 7th, this will be the first exam weeks, because the first exam will be February 9th, Friday. So at that week, there will be no quiz. So there will be, every week there will be something. And it can be either quiz or exam. Okay? So on Wednesday, March 6th, there will be spring break, March 13, exam 2, and so on. April 10, exam 3. Then April 24th, it will be a backup. So in case if there is any situation that we skipped one quiz, then it will be moved to here. It will be shifted to here. Okay, so that's all about the quizzes. Then I encourage you to add, there's something, I think I will publish an announcement soon, how to add this to the calendar, to Canvas calendar. I think add the Canvas calendar to Google or iCloud calendar. So here in this situation, if you follow the procedure, then all of the days will be assigned automatically to your calendar. Then you don't need to worry about missing a quiz or the exam. But again, keep in mind, every Wednesday there will be something. Or every week there will be something, a quiz or exam. Okay, so about the class professionalism, then attendance is mandatory, but I might take attendance randomly. So not frequently, maybe once a week, maybe once a month, once bi-weekly. So it depends on when I like see how's the class, how's the attendance of the class. So if I see lower number of attendance in the lecture, then I will take the attendance. Okay, then the other thing, like procedure, you can read it by yourself. Okay, so the homeworks, there will be some homeworks assigned, but these homeworks will not be collected. So I will assign it during the classes. So this is homework, or suggested problems. This, in other words. Then, basically, these problems will be assigned from the textbook, and these are important to complete your understanding of the course. So those problems are important to complete your understanding, and it's very important to practice these problems up to date. So when I assign them after, for example, this lecture, then you can review them after this lecture. Don't wait until the exam day. So the exam day, it must be a review for the lecture. So don't waste your time in spending a lot of time on the recommended problems and forgetting to study the lecture notes or skipping studying the lecture notes. The lecture notes are very important, while the recommended problems or homework problems are to complete your understanding. Okay, weekly quizzes, as I mentioned, it will be every Wednesday except the exams week, and it will be in the last 10 minutes. And these quizzes will be submitted using Canvas. So basically, on Canvas, you will see assignments. So most likely it is closed. For example, the first quiz, it will be open in January 17. So you will go to Canvas, then you will take a photo of your quiz, then submit it here through Canvas. So you will see a submission. So basically, you can either submit it as a picture, submit it as a PDF file, whatever. So during the quiz, the last 10 minutes, I will give you the quiz sheets. I will all provide it to you. Then you will write your name, ID, or email address, whatever. Then you will start answering the quiz. So when the quiz is done at 8:50, exactly 8:50, the quiz is done. Then you will take a photo using your cell phone and convert this to PDF or even like as a photo. That's fine. Submit this through the Canvas system. Then you don't need to return the paper to me. You can keep the quiz sheet with you. Keep in mind during the quiz. So once you are done and you touch your phone to submit the quiz, you are not allowed to write anything else. Then you are just submitting the quizzes. When you touch your phone, you are not allowed to write anything. And if you leave the classroom without submitting the quiz, that's your problem. You will lose this point. So keep in mind, after submitting the quiz, validate your submission. Some mistakes can happen. Sometimes you can submit wrong file. Sometimes submitted unsuccessfully. So keep in mind, check your submission before leaving the classroom. So if everything is all right, then that's fine, you're good to go. But if there is some problems, reach to me. I will be in the classroom. So if you have any difficulties, reach to me and I will help you in this. So you need to keep in mind, during the quiz day, bring your cell phone, iPad, or any device so you can take a photo and submit this. So you need to bring an electronic device during the exam day. Okay? During the quiz day. While the exams, it will not be like that. The exams will be as any regular exam, so you will return the test to me, and you don't need to submit this on Canvas. So I realized the best way to submit the quizzes using Canvas, it can be easier for me and for you as well. So the grader or the TA can grade the quiz, and it will be posted to you. So you don't need to come and return the quiz or pick it up. So it will be easy to follow. Okay, and the lowest quiz score will be dropped. So there are 10 quizzes, so 9 will be counted, and the lowest will be dropped. Makeup quizzes will be given only in case of university activities or document emergencies. So basically, this will be listed under excused absence. So if you have excused absence, then this will be, it can be counted as, or you can take the makeup quiz. So the makeup quiz most likely will be in the following Monday. So if you have any excused absence, you need to apply this. How it's being converted, or how we can consider this as an excused absence, I will discuss this later. But keep in mind the following, or the quiz, the makeup quiz will be in the following Monday at 9 a.m. Unannounced quizzes. The instructor reserves the right to give unannounced quizzes at any time during the course. Okay? So I'm not willing to do that, but if sometimes it can be, like last semester, I think I did this once. Okay, exams. There will be exam, as I mentioned, exam 1, 2, 3, and final exam. So the exams are closed note, closed books. The final exam will be cumulative. A handwritten 3x5-inch note card will be allowed in each exam. So you can write whatever you want on it. Just make sure, write your name, your ID or email. Then you can write 3x5, small note card. Okay, then we already have the exam dates. In case if we need to change the dates for any reason, you will be announced at least 1 week in advance. But I'm not willing to do that. I haven't done this in the past, but I mean, we have the right, I have the right, so 1 week in advance. Okay, makeup exams will be given only in case of excused absence. So, excused absence, here is the section. And makeup exams will be, again, in the following Monday, similar to the makeup quizzes, in the following Monday at 9 a.m., unless you have some problems like contradict with other classes or some other emergencies, then we can coordinate together. Okay, so the excused absence, how we can consider this as an excused absence, you need to submit a request to Engineering Student Services. So here in the course syllabus, there is a link. Then you can follow the link and submit an excused absence. So once you submit the documentation, they will validate this. Then they will send me an email and say like, this student has an approved excused absence. Then I will send you an email and tell you, or you have a makeup quiz in the following date, or in the following Monday, or does this time work for you? So we will manage this together. In case if your request has been declined for some reason, and you still think your absence is excused, please reach to me. Then we can make a meeting and just discuss. Then if I realize this is actually an excused absence, then I will keep this in mind. So I will be flexible in that. But it must be something convenient. Okay, computer usage. So keep in mind you need to check your email account at least once every 24 hours. So, and for example, some emergencies, like if lecture cancel for something like sickness or something like that, travel plan. But I'm not willing to do any of these urgent things. But sometimes emergencies can happen. So keep in mind you need to check your email. Sometimes I need to see you for a reason. Then you need to check your emails or check Canvas as well for any updates. When you send me an email, please keep in mind write ELEC 3810 in the title. Then you can write your title. So please make sure to write the course name, because I have other courses to teach. Then I need to make sure which course to be in the same page. Okay, calculator policy. So you are allowed to have a scientific calculator during the exams or the quizzes. That's fine. It can be, I recommend 2 types of calculators, TI 36X Pro or Casio FX115 ES Plus. So any type of calculators are fine, but you will realize after the first week, when we start discussing the AC, we will go to the complex numbers. And these complex numbers are very important, or we need to use them. This will take a lot of time. Therefore, you need to make sure how to use the calculator, or your calculator is supporting the complex numbers. So I recommend these two calculators because these two are supporting the complex numbers. However, if you have any type of calculators, that I'm fine. Even a graphical calculator, that's fine. But you need to practice, keep in mind, after the first month, you need to practice very well in the complex numbers, or you need to make sure your calculator is supporting the complex numbers. Okay, cell phone and electronic devices. So during the quizzes or the exams, you are not allowed to use a cell phone. Unless once you are done with the quiz and you need to submit the quiz, put your pen down. You are not allowed to write anything. Then when you touch your phone to make the submission, you are not allowed to write anything on the quiz sheets. This means you are already submitted the quiz. Then you need to keep in mind to submit it as soon as possible through the Canvas. Academic accommodation, please, if you have any accommodation, make sure to submit the request through the AU Access and do it as soon as possible because we have quizzes and exams, so keep in mind to do it. Test regrading policy, again, the TA will be responsible for the grading, while after reaching the TA, if you still have any questions, then you can reach to me. Okay, so the makeup, as I mentioned, it will be the following Monday at 9 a.m. Okay, so here are all of the dates of the quizzes, the exams, and the final exam. Okay, I think that's all about the syllabus. Now let's explore Canvas a little bit. So in Canvas, so the home page for the course syllabus, there is here a module. So here the module, this is another thing to find the textbook. You can either click on the course syllabus or you can go to module and you'll see vital source. This is for the textbook. Then you can explore the textbook here. And there are other type of modules, some demonstrative links that you can browse them during the lecture, during this semester. So for example, how's Ohm's law, how's electrical current. So basically, these have some demonstration videos. How about if we use conductor, or if you use insulator, something like that, some demonstration, and you will see how the electrons are moving. When we have a conductor, the electrons are moving from cathode to anode, something like that. So, and they have also different other than that. So we have some series parallel, capacitor, direct currents, alternative currents. So this sometimes can be useful to understand the concepts. Then files. So in files, you will see several files. So, okay. Let me make student view, yes. So here you will see worksheets. So these are basically complementary notes that we will use them during the lecture, other than lecture notes. So I can say, please refer to worksheet number 1, or refer to worksheet number 2. So you can find them here. I think those are about 15 worksheets. I don't know why it's not opening, but it should be available to you. Then we have completed notes. So completed notes, this include all of the notes that we will discuss in this lecture, and these notes are with answers. So you didn't need to write anything with me. While I have another notes are called to fill in notes. So to fill in notes, these are the notes that I will discuss during the lecture, but these notes without answers. So basically that's what I'm going to discuss during this lecture, this course. So you need to fill with me. So you have the option. You can either print or use the to fill in notes in your iPad or any electronic device, or print them in paper, and you can write them with me. So I'm going to follow through this and answer these sheets or answer to fill in notes. That's one way. Or there is another way. You don't need to write anything. you can look at the completed notes. So all of the answers are filled there. Then you just like pay attention to the lecture and that's it. So all of the sources are available to you. So you can see all of the lecture notes that we will cover in this course. Then what else? So here, a quizzes folder. Basically, there will be the quizzes answers will be posted here. The course syllabus as a PDF file, of course, here, and some solutions of the textbook problems. So during the this semester, I'm going to assign some homework problems. Again, these homeworks will not be collected, will not be graded. You will find their answers here. So their answers have already been provided. So what you need to do is basically when I assign some homeworks, try by yourself, then go to this folder, look at the answer, compare it with your answer, and realize you can see where are your mistakes. Okay? So it will be easy to follow. It's open access. Again, it's available for everyone. Then there is nothing hidden. All of the quizzes answers will be posted. All of the lecture notes are available, either to fill in or to complete the notes. The textbook is available as well. And in Canvas, you can see Panopto recordings. So I'm willing to record these lectures. Even like today's lecture is recorded. So you can see here, recording right now. So I'm recording today's lecture as well. So all of the lectures can be available here. Then again, if, for example, you need to study for the test or study for the quiz, and you misunderstand something, or you need to make sure to review some topic, you can go back to the recordings. If, for example, you had a travel plan, something that you need to go, or if you were sick, you cannot come to class, then all of the lectures are available to you. So this will be, I think, useful for you and for me as well. Then you can follow the lecture notes. I think that's what we have on Canvas. So during this semester, or during the lectures, when you have any question, please raise your hand and ask your question. Or if you need a clarification about some topic, raise your hand and tell me I need to, or please explain this again. If you find me going too fast, tell me that you're going too fast. I can explain it to you. But if we see that this question takes a lot of time, or you are taking a lot of time of the lecture time, then you can keep it to the office hours or after class. Okay? Okay, now, any question about the course syllabus or Canvas? Okay, let's go to the overview or to the first set of notes. So you can find, let me just go back here again, to fill in notes, files, to fill in notes in chapter 1, the first one. That's what we will go through. Okay, introduction and fundamental concepts. So you will see some concepts, especially like in the beginning of this course, are very similar to what you know from Physics 2. Like capacitor, resistor, inductor, voltage source, something like that, or battery, etc. But here we will discuss this in different way. I mean, it's very similar. This does not mean what physics is wrong. No, physics is correct, but we have a standards in electrical engineering. So we will use some standards that can be kind of different from physics. So especially in solving some techniques, circuit analysis or some techniques. So again, here we are trying to learn a language. So we are trying to standardize this. So the language of electrical engineering. Okay, so what's now a question? What's the difference between the College of Engineering and the College of Science? Or the science and engineering?
Engineering is the application of science.
Exactly. Engineering is the application of science. So that's what we will focus here, most likely about the practical parts. So sometimes maybe during the first month we will go some circuit analysis, but it will not be a lot of practical part. But later, in the second month, we will go for more applications. So how can we use the resistor in real life? What does capacitor mean in real life? Or the inductor? Basically, it's based on modeling. So the first thing we will learn the circuit analysis, how to do the circuit analysis, then we will learn the model of this thing. So for example, the motor, we can model the motor to be a small circuit, equivalent circuit. So it can be a combination of resistors and inductance. So we can model the motor to be resistor and inductor, then we can do our circuit techniques. So now we have the concept of the motor. I mean, this circuit is a circuit of motor. This is a circuit of, for example, transformer, etc. Then we are doing some applications. That's the overall thing about engineering and application science. Now the other thing, which is, what's the difference between the technicians and the engineers? Any thoughts? What do you think? How can we know that you are an engineer or you are technicians? Or I mean the difference. Or when you are working with, let's say like in a manufacturer, and we say we need an engineer or we need a technician. Yes?
Technicians fix problems, engineers solve problems.
Yes, so exactly. So I can say that technicians sometimes know how to operate these things. Engineers, again, know how to operate these things. But the other thing about problem solving, how we or why this thing has been operated or this machine is operated, then the engineers knows how. It's not only how to operate this, which is about the fundamental concept, why this thing is working, or what's the problem of this. So engineers are basically application of science, and in addition to this, problem solvers. So that's why if there's any problem, come on, call the engineer. He's a problem solver. That's your job, solving problems. Okay? Then our jobs are problem solvers, again, like application of science. Then when we have a problems or when we do things, then we need to know why this thing is working or why we are using this thing. Then that's why I need you to think about when we discuss even electrical engineering course or any other different courses, which is why we are using this thing. What's the point of using this other than the other thing? I need you to ask you this question. So for example, through this circuit, this course, we will go to DC circuit analysis, then we will go to AC circuit, then we will go to three-phase system. So the first thing that you need to ask yourself, not take it as is, why we are using AC? Why we didn't say that DC is fine? Or why we are using three-phase system? What's the point of using three-phase? Since AC or single phase is working or AC circuit single phase is working, why we are using three-phase? That's these kind of questions that I like, which is understanding what's going on. Not only take this information as is without thinking. So we need to think how or think more, because when you think and understand what's the point, then this will remain in your mind. Then you will not forget this. I know maybe after the end of this course, after 1 week or 2 weeks, you will forget most of the equations that we are using. But if you are understanding Ohm's law, you will keep understanding this. If you know how to use Kirchhoff's laws, then you will know how to use them because you are understanding this, not because if you are memorizing this or just do this and this. Okay? So that's the thing that I need you to make a critical thinking during these lectures. So keep asking yourself why we have this thing. If you cannot get an answer, feel free to ask me. And if I cannot find an answer, I will find it for you. Okay? So we need to make sure that I don't want to have one way of the way of teaching method, so we have 2 ways. So feel free to ask. When I ask any questions, also feel free to answer. Even if it's wrong, that's fine. Feel free to answer. That's fine. Okay, so in chapter 1, let's go to the definition of the electricity. So when I say electricity, what does this mean? Or how can I know there is electricity here? What does electricity mean? Any thoughts? There is electricity here. How can I know? Detect. Yes.
Flow of electrons, or like the movement of electrons?
Flow of electrons or moving of electrons. Or I would say like the presence of electrons, right? Yes. So the electricity can be either static or dynamic. This is the presence of electron or presence of charge. So it can be either static or dynamics. Static, like static electricity. Sometimes when you touch surfaces, you will see some shocks. Or dynamic electricity or moving electricity, which is the electrical currents, that the regular electricity that we are using this to power up the lights, power up our devices. So again, how can I know there is electricity? It's by the presence of charge. So for example, we have a digital multimeter or DMM that we are using this to measure, for example, the voltage. So how can I know there is an electricity in this wall outlets? You will bring a DMM and put it into the socket, inside the sockets. Then if you have a reading, then there is electricity. If we turn the power off, the circuit breaker off, and measure, there is no electricity. That's how we know which is the presence of charge. Or sometimes when you have a tester, sometimes it will tell you like if there is electricity. So basically, you are testing if there is any presence of charge. Okay? That's the electricity. So the charge is, as we know in physics, it's from Coulomb. We can measure from Coulomb. It can be Q of T, which is if these charges are moving. Then the electrical currents is the moving of charge, which can be only with moving electricity or dynamic electricity, not the static. So which is the moving of charge. So when these charges are moving, this is considered as an electrical current, or in other words, we can call it currents, which is the moving of these charges. So without charge be moving, you will not see the lights bulb on, or you will not charge your phone. So these charges, moving of charges, can be in batteries, can be in sources like in the power utility sockets, or it can be everywhere where there is electricity. The current, again, is the moving of charge. And the current is measure how much charge is moving per unit of time. And it can be coulomb per second. So which is the speed of the moving of these electrons or charge. So since the speed is the derivative of the position or derivative of something like that, then here the speed of charge is the derivative of the charge. So it's the time derivative dq by dt, such that q of t, because the charges are moving with time, then the derivative is the electrical currents. Then the current is measured by units ampere. As a shortcut, we call it A. I think you are familiar with this, but here again, we're going overview on. Then the electrical currents, again, moving of the electricity. So let's assume we are with point A here, and here is point B. And there is a wire between this. So the currents moving from A towards B. So I would say IAB, as an example, equals to 5 amperes. So we are moving from point A to point B. So the moving of this charge from A to B is called electrical current with respect to the time. So the time derivative, dq of t by dt. This is the currents. Keep in mind, in order to make our standard or our assumptions, the current directions is the opposites of the electron flows. What does this mean? I'm assuming the current going from point A to point B. The electron flow in real life goes in the opposite way. So the electrons are moving from B to A. Why? What's the point? Why we are assuming the current direction is the opposite of the electron flows? Because of the negative charge of the electrons. The electrons have a negative charge. And as we know in vectors, the negative charge means opposite direction. So when we see some electrons moving like this way, from right to left, it's negative charge. Now, negative charge means opposite direction. So the real direction is left to right, right? That's what does it mean. That's why the currents is the opposite direction, because of the negative charge of the electrons. And in mathematics, again, as we know in vectors, the negative charge means 180 degrees phase shift, or in other words, opposite direction. What are the type of charges? The type of charges can be electrons. Most likely, as we know, like the electrons can be like from different combinations. Like we know, for example, Na, the valence, the last electron. there is an electron of it in the valence. So there is only one electron. So there is extra electron, which means Na can lose this electron to move to another part. So this can be, the electrons are part of the charge. And we have something we call it positive ions and holes. What do I mean by this? When we have, again, NaCl, if you try to divide it, it's Na plus Cl minus, right? What does it mean Na plus? This means the valence is 0 because the electron has been moved. So there is a lack of electron, right? So this is positive ion. And we have holes. When the electron moves to the Cl, this produces a charge as well. So those are type of charges: positive ions, holes, and electrons. Okay? Most likely, the main source we would say is the electron itself. I mean, the effect of the electron, when the electron is moving, causing the moving of this electron causing an electrical charge. Okay? And again, in the demonstrative video that I showed you, let me show you again, which is in course modules. So this is positive, this is negative. So if we put a conductor, the current actually moving from positive to negative, or that's the electrical current, while the electrons are moving in the opposite direction. Come on. So the current is supposed to flow from positive to negative, while the electrons are moving in the opposite direction. Why? Because the electrons are negative charges. Okay, this is one way of how the electrons are flow. Now I have also a question. So if you move this conductor, now the electrons will not flow, will keep going here. This means there is no electrical current going. Why? Because it's open circuit, right? It's open circuit, means there is no closed path the current to flow. So the current will go from positive to negative. Here it goes from positive, keep going, but it will not back to negative because it's open path. Therefore, whenever there is open path, there is no way for the current to flow. Another way, if you put insulator instead of conductor, of course, then the electrons are keep flowing through the atom, it will not go. Then the electrical current will not flow because the isolator or the insulator will isolate the electrons. So there will be no current to flow. Okay? So even you can look at the wall sockets here, the wall socket out. Then this wall sockets, if you bring a digital multimeter and measure the electricity, there's electricity, you will have some readings. Okay, so there is electricity, but why the current will not flow? Because it's open circuits. When you connect a device, you are completing a circuit. Okay? Now, how about the voltage? What does the voltage mean? Why we are interested in this? The voltage means the measure of energy transfer capability via charge flow. And it is joule per coulomb. So which is the time derivative of the energy or of the work with respect to the charge. And the unit is joule per coulomb, or in other words, I will say this is volts. So let's assume we have a system here, and this system, there is point A, point B, plus minus. So I will say, since the positive at A, the negative at B, I will say this is VAB. However, if I flip them, if I put the negative at A, the positive at B, I will say this is VBA. Okay? So when I say VAB or VBA, the first letter will be at the positive, then the second letter will be at the negative. Okay? So this every time when there is a voltage must be a difference or potential difference. Voltage difference. It must be with respect to something. I cannot say VA alone with respect to something, or VB alone. So it must be with a reference, VAB, potential difference. And this is measures the capability of energy transfer. So the higher voltage, the higher way to energy transfer to deliver a current or to transfer electrical charge flow. That's why when we have high voltage, this means we have higher energy capability or higher number of electrons can flow or charge can flow. This means this is dangerous, means a lot of electricity. When we have a lower voltages, lower energy transfer capability or lower electrons transfer capability. And the voltages can be either drop or rise. Drop means A is higher potential than B. That's why this means also we are moving from positive to negative. That's why we can say VAB is rise or it's drop because we are going from positive to negative. While rise, if we are going from lower potential to higher, if we are going from negative to positive, this means it is called rise, which is going from low to high. Let's assume this scenario. Here is system, and I would say this is A, this is B. This is different scenario than the previous one. So when I say VAB, so is it the positive at A, the negative at B? Yes. Therefore, it will be drop because going high to low. But when I say VBA, it is the opposites because we have negative at A, the positive at B. So we are going from low to high. This will be rise. Okay? Because this is different than our assumption. We are going from negative to positive. Again, drop going from positive to negative, rise going from negative to positive. That's the clue, that's the point. Positive to negative or negative to positive. Okay, now there are a lot of similarities between the electricity and the water. Pipelines, similar to what in electricity? What do you think?
Wires.
Wires, right. Water, the water is moving in the pipelines. What's very similar to the electricity? Yes?
Electrons?
Electrons. Or more generic, we can say as well, charge, which is the same, electrons. Water flowing, electron flowing, right? So electron flowing is what? Currents. So I would say electrical currents. Water flowing is water currents. Then electron flowing is electrical currents. Okay, let me fix, I'm sorry. Now the pressure, voltage. Pressure is the potential of the water to flow. Then the potential of the electrons to flow is the voltage. So is the voltage. Okay? So does this make sense? So again, there are a lot of similarities between the water and the electricity. Pipelines, wires, water, electrons, flow of water, water current, electrical currents, voltage, pressure. So next lecture, I will go more in the water pump example. So that's it for today. See you on Friday. Thank you.